So at this point you should have completed your multiple choice quiz. It was a 15 minutes quiz with 7 questions, and one of them won't count, so highest score will be out of 6 questions. The homework check for today is for number 13, 10 plus 5 points. If you have questions from that homework, if there's any time left at the end of class, you can ask them. Otherwise, you will have to come back during lunch to ask questions. We are going to do review number 14 notes, so Ms. Denman, if you can make sure they have those packets. I am going to go over the notes with them now. So FTC 1, yesterday we did FTC 2. So FTC 1 was the fact of taking a derivative of an integral from a constant number, whatever that constant is, to a function. I'm actually just going to call it g of x, that might be easier. Of a function f of t, dt, let's say, would be that you would set this into the function here. So your x's, every single x that you see, turns into whatever that g of x is, and then you multiply by the g prime of x. So the derivative of this guy. And an important thing to remember is that this down here has to be the constant. It has to go from a constant to a function, and if not, you're going to have to use the rule of negating the integral. So we end up using, let's see, I'm not exactly sure why I placed this in this lesson, but I will go through, because this packet, I believe, has particle motion. So displacement. Displacement is the integral from a to b of plain old velocity. That's one way to say displacement. There's also a formula for displacement if you know the position function, ending position minus the beginning function. That definition actually comes from the integral because the antiderivative would have been position, f of b minus f of a. Position. Position function, s of b is equal to s of a plus the integral from a to b of v of t. That's one way to find position. The other way to find position is using velocity, finding the integral of velocity and adding the c value and solving for it. But to find an ending position, remember you need an initial value. Either way you do the problem, either you need an initial value here or you'll need the initial value to solve for c. Total distance. I'm actually going to add that to the next page because we're going to have to look at total distance a few different ways. So the easiest way is with a calculator. If you get a calculator, total distance is equal to the integral from a to b of the absolute value of velocity, which is exactly the same thing as speed. And total distance will be equal to displacement if the velocity is always positive or equal to 0. So they'll actually be exactly the same thing. If you're trying to find total distance by hand, we say, algebraically, step 1, v of t zeros, or x-intercepts. Number 2, sign chart of v of t. And then number 3, add positive integrals. And subtract negative integrals. All right. Next, average velocity we talked about yesterday, just reminding you that there are 2 different ways. I'm actually going to skip over just to save a little bit of time. I'm going to skip over average acceleration and average velocity and only do speed. If I could. So just a reminder about speed. We've done speed with derivatives, but speed is equal to the absolute value of velocity. They're not the same thing unless velocity is positive. And speeding up versus slowing down. You see how important this concept is. I repeat it over and over and over. Speeding up is where your velocity and acceleration have the same sign. And then slowing down is where velocity and acceleration have different signs or opposite signs. And what's nice is if I ask you if a particle is speeding up or slowing down at time equal to 2, I don't need a sign chart at all. I just need to find the velocity at 2, and I need to find the acceleration at 2, and figure out if they're the same sign or opposite sign. Alright, so at this point I'm just going to do some example problems for you. Again, if we are out of time, Ms. Stedman, you can pause this and the students can watch the video on their own at home because it'll be on YouTube. So starting off with number 2 in your packets, velocity is given. How far does the particle move between time equal to 1 and time equal to 2? That question is just asking you displacement. So displacement would be the integral from 1 to 2 of the velocity. That's the definition of displacement. So that would be 1/3 t cubed. F of 2 would be 8/3. F of 1 would be 1/3. And 8 minus 1 would be 7/3. Number 14. So f prime of x. So f prime would be if I took the derivative of both sides of this little equation here. So you end up with the derivative of the integral from 1 to x squared of 1 plus t cubed dt. So first thing, if I'm taking the derivative of an integral, it's as if they're going to cancel. Everywhere that I see a t, I'm going to replace it with this function. So, first of all, these in a sense will cancel each other, and we won't have that anymore. I'm going to have 1 plus t, which is x squared, then the whole thing cubed, and then multiplied by the derivative of the g function up there, which would be 2x. So that would be the integral, or not the integral, the square root of 1 plus x to the 6th times 2x, which is a. And this actually came from your Chapter 5 test, and Ms. Stedman, I have copies for the students. Well, actually, if they want to take out their Chapter 5 test and go over this question one more time, I actually made a video online for all of the free response questions from Chapter 5 test. This one was an interesting one because it was using FTC 1, and you can tell that FTC 1 will get used because of this statement, but the way it was used was interesting. So I'm actually going to start out just with part A. I'm not going to do the whole problem again, but just a reminder of how to find g prime of x. G prime would be the derivative of that piece, plus if I found the derivative of this guy right here, I would substitute in my x and multiply it by the derivative of x, which happens to be 1. So you just get 2 plus f of x. So it changes the problem because if I want to find where g increases or decreases, I would have to set this guy equal to 0, which is kind of interesting because part B does have you find a maximum, and if I want to find a maximum, we set its derivative equal to 0. That's where a lot of you guys got the problem wrong because you forgot that the derivative has that extra 2 in it. Okay, that is it.